Hello everyone. Today in this video we are going to discuss about the different properties of rational numbers. Now there are different properties of rational numbers. So today we'll be discussing only three properties of rational numbers. Now these properties of rational numbers depends upon the operations that are being performed on the rational number. So let us start first with the closure property. Now in the closure property, when the operation is addition, then what we get is the sum of two rational numbers is again a rational numbers. That is, when we add any two rational numbers, the answer will always be another rational numbers. Say for example, here we have given 2 by 7 and 3 by 7. The answer that we get here is 5 by 7. Here the denominators were the same, so there was no confusion in this simplification. But when the denominator is not the same, then what you have to do, we just have to take the LCM and then cross multiply the numerator and the denominator. So again in this case we get another rational number. Now let us see in the subtraction. In the subtraction also it is the same thing. When you subtract or find out the difference between two rational numbers, the answer is always another rational number. We have taken the same example, just we have changed the operation from plus to minus. So as you can see, in both the cases, the answer is a rational number. Now in the third, that is in the multiplication, when the operation is multiplication, what do we get? The product of two rational numbers is again a rational number. Here also the closure property is valid. You can see if you multiply, here the multiplication is very simple. Just try to multiply the numerator with the numerator and the denominator with the denominator. And the answer that we get here is a rational number. If we go on to division, the division of two rational numbers is again a rational number, but there is a condition that the denominator must not be equal to 0. What will happen if the denominator is equal to 0? Then as we know, the solution is not defined. Say for example 2 by 0. Do we know the answer? No. It is infinity, or we can say it is not defined. But in this case, as you can see, now you might be confused. There is a division symbol here, but I have taken a multiplication. This is just a easy way of carrying out the division. If we have to do the division of two rational numbers, it's very simple. Say for example here 2 by 7 divided by 3 by 5. What we have to do is we have to keep the first rational number as it is, 2 by 7, and then we have to multiply with the reciprocal of the next number. So the answer that we get is another rational number. So I hope you have understood this thing. Now moving on with the next property. The next property is the commutative property. Now in the commutative property, what it says, two rational numbers can be added in any order. Say if we have two rational numbers a and b, then this is the order, that a plus b should be equal to b plus a. This is the commutative property. Now let us see in case of addition what it happens. So in case of addition, as you can see, we have taken two rational numbers, 2 by 7 and 3 by 7. The answer that we get here is 5 by 7. Now let us see the other way around. 3 by 7 plus 2 by 7. Again the answer is as it is. If we take some negative rational numbers, then you can see here the answer is same. Here also what we have taken is, since the denominators are not same, so we have taken just the LCM of it. So in both the cases we get that in case of addition, the commutative property holds. Now in case of subtraction, the same thing, but here the answer that we get is different. So we can say that in case of subtraction, the commutative property does not hold. Since you can see here, the answer here is minus 1 by 3 and here it is 1 by 3. You can try out other examples also. It is for every case you will find out that when we subtract two rational numbers, then the commutative property does not hold. That is, a minus b is not equal to b minus a. Now in moving on with multiplication now, in case of multiplication it holds, because if we multiply a into b, where a and b are two rational numbers, then obviously b into a will also be the same. So for example, here you have taken minus 2 by 11 and 5 by 7. The answer is minus 10 by 77. Similarly, if we just do the opposite, that is 5 by 7 into minus 2 by 11, the answer will be same. So it holds. Now in case of division, what is written here? Two rational numbers cannot be divided. Yes. If we have to find out the division of two rational numbers, then the commutative property does not hold. That is, a divided by b will not be equal to b divided by a. An example is I have taken here 2 by 7 divided by 3 by 5. The answer is 10 by 21. And here in this case, the answer is 21 by 10. So it is opposite. The answers are different. So the commutative property does not hold in case of division of two rational numbers. Now moving on with the third property of rational numbers, that is the associative property. Here also the rational numbers have to follow an order, but here we will be taking three rational numbers instead of two rational numbers that we have taken in commutative property. Here we will be taking three rational numbers a, b and c, and the order is this: a plus inside bracket b plus c should be equal to a plus b inside bracket plus c. So this is the associative property. So let us take one example. We have taken three rational numbers, minus 2 by 3, 3 by 5 and minus 5 by 6. So as you can see, this is the simplification. First of all, we have to simplify the thing that is inside the bracket according to the Bodmer's rule. So inside the bracket, as you can see, we have solved this first, then we have added to the other rational number that is outside the bracket. So the answer that we get here is minus 9 by 10. Let us see if we do the other way around. If we take this first two rational numbers inside the bracket, the answer is same, minus 9 by 10. So we can say the associative property holds in case of addition operation. Now in case of subtraction, no, it does not hold. Let us see how it does not hold. Here a inside bracket b minus c is not equal to a minus b inside bracket minus c. So I have taken the same example. No, I have not taken the same example. I have taken a different example, but you can see the process is same. Inside the bracket, first we have simplified that, and then we have simplified what is remaining outside the bracket. So here we got 19 by 30, and in the other case we got minus 11 by 30. So here clearly the subtraction operation does not hold the associative property of rational numbers. In case of multiplication, yes, definitely it will hold. That is, a into b into c inside bracket will be equal to a into b inside bracket into c. So I have taken some examples, you can see. So here 35, the answer is same, minus 35 by 54 in both the cases. So in case of multiplication, the associative property holds. Now division, again, it does not hold. Here is one example, you can see. The first case, the answer that we get here is 3 by minus 5, and here we get the answer is minus 3. So that's all. So what we have learned today is three properties of rational numbers, that is the closure property, the commutative property and the associative property. The next day we will deal with other properties of rational numbers. So today what I have explained, please go through the textbook, and you can also try out with other examples if you want, so that you have a better understanding of these three properties of rational numbers. So that's it in this video. Hope you all have understood it. Thank you and have a nice day.